All right, page 49. So this looks like the hospital, right? You pronounce it l'hôpital, okay? L'hôpital. L'hôpital. Anybody in here take French? L'hôpital, okay? You can go and press Miss Christensen if you're in there now. Okay, so in Unit 1, we spent a large amount of time worrying about what a limit is and how to find them using algebra. Okay, one of the lessons, horizontal asymptotes, looked at limits as they approach infinity. In order to evaluate those limits, we needed to identify which of the numerator and denominator had the fastest growth rate in order to determine our limits. Today we will learn how to apply growth rates in order to solve most limit problems. So not all limit problems, but most limit problems, including ones we otherwise wouldn't be able to use or wouldn't be able to solve using algebra. Okay? So here is L'Hôpital's rule. Here's how you spell it French-like. I guess you can call it La Hospital if you want to. If you want to sound uncultured. La Hospital. All right, suppose that f and g are differentiable functions, okay? If they're differentiable, they are also what? Continuous. Okay. Functions that in g prime of x does not equal 0 near a except possibly at a. Suppose that, here we go. So let's suppose that the limit as x approaches a of f and g are both 0, okay? Or that the limit as x approaches a of f and g are infinity. So if that happens, then we would get 0 over 0, because remember it says, so if we find the limit of f of x over g of x like this, we'd put 0 over 0. 0 over 0 is the indeterminate. Not only can you not divide by 0, 0 over 0 has a special name, and we can't say what that limit is like that. So if we get 0 over 0 or infinity over infinity, then we use L'Hôpital's rule, which says that the limit as x approaches a of f of x over g of x equals the limit as x approaches a of the derivative of the two. Okay, so you basically just take the derivative of the numerator, derivative of the denominator, then try to evaluate your limit. If the limit on the right side exists or is plus or minus infinity. Okay, so basically here's what happens. If I take this right here, and if you recall, when we were doing limits at the beginning, I was having you write it separately sometimes, and I think that was leading to some confusion. But when you go to evaluate this, the first thing you want to do before trying to do any kind of weird stuff is to just see if you can substitute it in. So when we do that, we're going to do this, the top and the bottom. So the limit as x approaches 3 of x squared minus 9, and the limit as x approaches 3 of x squared minus 5x plus 6. Okay, so we find those two limits just by direct substitution. So if I substitute in 3 here, that's going to give me 9 minus 9, which is 0. When I substitute 3 in here, that's going to give me 9 minus 15 plus 6, which also gives me 0. If I had gotten anything besides 0 over 0, if the first one had, so if I got 0 here and 3 here, that would be 0 over 3, and my answer would be 0, right? If I got 3 here and 0 here, I'd have 3 over 0, undefined. If I had 3 and 1, then it would be 3 over 1, and it's 1, right? That's how we do the top and the bottom, and then we can make a fraction out of them, but this gives me 0 over 0. But I'm not writing it, because we never want to say anything equals 0 over 0, right? So since this happened, and I get that indeterminate form, then I'm going to say, therefore, by L'Hôpital, and you can just leave the S out, or you can write hospital. It doesn't matter. We're going to say the limit as x approaches 3. Now, I'm not going to separate top and bottom. Here's where you can have a little bit of freedom in what you do. We could separate the top and bottom again, but when I do this and I'm going to take the derivative of the numerator. What's the derivative here? 2x, okay? So now when I substitute in 3, is that going to give me 0 or infinity? No, so then I don't need to worry about separating, right? We only need to do that if we're going to get that. So then I take the derivative of the denominator, That's going to give me 2x minus 5, right? And so now can we just do direct substitution? Yes. And this is going to give me 2 times 3 over 2 times 3 minus 5, which gives me 6 over what? 1, which I can leave like that or make it 6. Let me go back and grab my notes so I can. Right. What questions you got? Well, now let's think about how we did this before. When we did this before and we got 0 over 0, I don't need my notes, but I like to have them. Let's make a little arrow here because we don't have a lot of room. What we did before when it didn't work with direct substitution is we tried to factor. So up here, if I could take this and I could factor it, and I could say that the limit as x approaches 3, and then when I factor the numerator, that becomes x plus 3 times x minus 3. And then denominator is x minus 2 times x minus 3. Right? Then I can cancel those out. Then what I'm left with, I can do direct substitution here, and I'd get 3 plus 3 over 3 minus 2, which still gives me 6 over 1. So in this case, I have 2 different ways to do it. I know y'all don't love factoring. Would you say that the derivative way is a little bit easier? That's why we talk about it, but we don't spend a ton of time there because we do have some options. Now you can use L'Hopital, where you just separate them, take the derivative of both. Okay? Does that make sense? Yes? L'Hopital? Okay. Okay. Or infinity over infinity. Make sense? So if that was as x approaches infinity, then I would end up with infinity over infinity when I substituted in. Right, exactly. Okay, so either one. But we'll talk about infinity and how we actually, what's another easier way to do infinity as well. Okay, we'll get there. Okay, so let's do this one. We're going to show that the limit as a approaches negative 4 of 1 over a plus 1 over 4, what does that equal? 0, right? Does it be negative 1/4 plus 1/4? If you need to write it out, you can. But if I substituted negative 4 right there, I'm going to give you, yeah, it's going to 0 out. And then the limit as x approaches not x, that is an a. As a approaches negative 4 of a plus 4, what's that going to give me? 0. Okay. Now, in order to use L'Hopital's rule, you have to show that. You can't just say, okay, you can't look at it and go, I know that's going to happen, so I'm just going to go ahead and take the derivatives. You have to show that you get the zeros, or you show that you get the infinities. But again, we don't actually write 0 over 0 because nothing equals that. So then I can say, therefore, by L'Hopital, then I'm going to find the limit as a approaches negative 4 of, all right, so in the denominator, what's the derivative of this one? 1, okay? I'll just put a 1 there. The numerator, what's the derivative of the second term? 0. So all I have to worry about is this one, right? Should I maybe rewrite it or a different way and think about it a little bit differently? A to the negative 1. I'd put a to the negative 1 power. That's the same thing as that right there, right? So that when you take the derivative, you multiply the negative 1 out front, right? So that's negative 1 times a to the what? Negative 2 power. And a to the negative 2 power is the same as 1 over a squared. Y'all agree with that? I mean, you can write a to the negative 2, but you would need to rewrite it in that form. So it makes sense to you in the end. Oh. Eraser's too big. Make that a little bit shorter. There we go. Do I need to do that? So a to the negative 1, I get negative 1 times a to the negative 2 power, and then that's why I get negative 1 over a squared. All right, so then when I substitute in the negative 4, what do I get? Negative 1 over 16. I know I'm asking really difficult questions. Everybody okay with that? What questions you got? All right, so go ahead and write out the first part of this for the next one. Did you get this far? Yeah? All right, now take the derivatives. Is it going to be chain? Yes. Do you have something under the square root besides an x or besides a variable? Yes, so technically it is chain. So let's talk about this derivative if we need to. When you take b plus 4 to the 1/2 power, I multiply the 1/2 out in front, leave the inside alone. Then I subtract 1, that gives me a negative 1/2. Then I multiply by the derivative of the inside, which happens to be 1, but this is what I get here. Now, when your denominator is 1, is my denominator even relevant at all? No, so I didn't necessarily even have to put it, right? I didn't have to necessarily think of it as a fraction. So this is the same thing as just 1 over 2 times the square root of b plus 4. You can write it either way. But if this is less confusing, you're less likely to do something weird. That'd be nice. So I substitute in 5. 5 plus 4 is 9. So in the end, I get 1 what? 6. Okay. What questions do you have? We good? All right. You try this one. You can do it. Don't look at me like that. You got this. Pi halves, it's 90. Okay? It's okay. You can get a limit that's 0. You just can't get 0 over 0, right? Good? All right, try the next one. Do the next one. You want to be a math anarchist and not have to do the rules? What? Yeah, you won't have to do math at all if you major in physics. There's no math there. What's the natural log of 1? 0. Are you guessing? Okay, remember this. Logs are related to exponentials, yes? You know an exponential looks like this, right? Anything to the 0 power is 1. These are the log is the inverse. So if this is 0, 1, this is 1, 0, the log of 1 is 0. Okay? Think of the parent functions like that. That can help you get your mind wrapped around it. All right, finish this up. What changed signs? Okay. So this gives me 1 minus 1 over 2 times 1, 0 over 2, which is 0. Okay. When I substitute here, I'm going to erase all that. I'm going to call that because I need the room. When you substitute this in, you get 1 minus 1, which is just 0 over 2, which is just 0. We good with that? All right. Work on the next one. what happens here? You get 0 over 0. Are you allowed to get 0 over 0? No. Should you write 0 over 0 as your answer? No. Okay, so notice on these other ones, so listen, when I didn't split things up here, I can tell by looking that when I substitute in 1 to the denominator, I'm not going to get 0, so it's fine. When I substitute 0 in the denominator there, I'm going to get 0. And in the numerator, I'm going to get 0. And so I'm going to need to split it again. Okay? You got to do it again. You can keep on going. All right? So then we're going to say the limit as x approaches 0 of e to the x minus 1 equals 0. And the limit as x approaches 0 of 2x equals 0. Okay? Then we say again, therefore, by L'Hopital again, once again, this is what allows us to do this. The limit as x approaches, I got my 0 here, 0 of, what's the derivative of this? E to the x. What's the derivative of this? 2. What is my answer? 0? 1/2. It's not 0, it's 1/2. So you might have to do it twice. If you end up getting 0 over 0 again, just make sure you separate them and show that that's what's happening, and then we move on again. Okay? You can keep going and keep going and keep going. You won't have to go more than that. Okay? What questions we got? We good? All right. So let's see where some examples of where L'Hopital's rule fails to work. So we're going to split this again. So the limit as x approaches 3 of 2x squared plus 7x minus 4 equals, and the limit as x approaches 3 of 2x minus 1 equals. So when you substitute 3 in the numerator, what do you get? $35. Good job. And when we substitute it in the denominator, we get 5. Okay. All right. So now, you want to take the derivative? Therefore, why not? Because it's not 0 and 0, right? All right. So what's my answer? It is 35 over 5, 7. Because remember, direct substitution is fine, and that's actually what we've been doing. We've just been getting 0 over 0. That's why we had to do L'Hopital. If you do direct substitution and you get an answer, you're done. Okay? So I want you to see what happens by L'Hopital. And why you can't just use it any old time you want to. If we did the limit as x approaches 3, yeah, write this down. So when I take the derivative of the numerator, I'm going to get 4x plus 7, right? And then this just would give me 2. So that's going to give me 19 over 2. I get an answer. Is it the right answer? No, because you can't use L'Hopital, right? So it's not like you get the same thing, where on the very first question we did, whether you factored and figured it out or you did L'Hopital, you'd have gotten the same answer, but that doesn't work that way. Okay? We okay with that? What questions you got? Okay. So let's look at this next one here. The limit as x approaches infinity of the square root of 4x squared plus 3, and the limit as x approaches infinity of x plus 2. Okay, well, if I substitute in infinity, which you can't technically substitute in infinity, but what are the limits here? As x approaches infinity, what is this going to be approaching? infinity, right? So we're going to put infinities. Notice there's no equal signs because we can't say that it equals infinity. But we'd end up with infinity over infinity, right? So then that's where we want to do the derivative. So therefore, by L'Hopital, the limit as x approaches infinity, what's the derivative of this part right here? 1. So really, I don't have to worry about the denominator, right? It's just 1. I need to take the derivative of this. So let's look at that. That's going to be 4x squared plus 3 to the 1/2 power. So when I take the derivative, it's going to give me 1/2 times 4x squared plus 3 to the negative 1/2 times what? 8x, because it's the chain rule, right? So then when I put that in right here, that gives me 1 over 2 times the square root of 4x squared plus 3. But then I also have an 8x in the numerator. Can I reduce that? You understand why I have an 8x in the numerator? Yeah, because I had that right there, and that's not the denominator. So, but then I can reduce the 8 and the 2. So this gives me 4x over the square root of 4x squared plus 3. All right, when I substitute in infinity again, am I going to get infinity over infinity? I am. So when I separate it, we say the limit as x approaches infinity of 4x is going to give me infinity, and the limit as x approaches infinity of the square root of 4x squared plus 3 is going to give me what? Infinity. So now I'm going to take the derivative again, right? So you might have to go over here if you don't have a lot of room. Let's say, therefore, by L'Hopital, and I'll say the limit as x approaches infinity. Do we know what the derivative of this is? What's the derivative of this? It's this right here, right? Because look, we took this derivative, and we put it in here, and then we just simplified it. So when I take that derivative again, guess what I'm going to get? Exact same thing, right? In the denominator, I'm going to get that exact same thing, and then what do I get in the numerator? 4. Okay, so that'll give me 4 over 4x over the square root of 4x squared plus 3. When you simplify that, you're going to get the square root of 4x squared plus 3 over x. What does that look very similar to? Very similar to this. It's not exactly the same though, right? But it's the same, but it's similar. And so then if I took the square root again, wouldn't it just flip to the denominator? And then flip to the numerator? And I just keep going back, and I just keep, you're in a mad circle of stuff, right? So instead, even though this one gives me infinity over infinity, let's talk about what our answer is. When we're talking about as x approaches infinity, we're talking in behavior. Those are our horizontal asymptotes, okay? Is this one top heavy, bottom heavy, or tied in degree? Is it really? Is it really? We look at this. What's the square root of 4x squared? 2x. So this is 2x over x. It's actually tied in degree, and this would equal 2. Okay. We good with that? So at the infinities, you really just think about your asymptotes. It's way easier than doing anything else. Okay. What questions you got? 2 is the actual answer, yeah. But this is why it fails. That's why I'm just showing you that we could keep going. We literally go forever. We don't want to go forever. Okay, so you do have one more piece of paper for the notes, but there's only 2 little questions on here. It just didn't fit. I didn't want to cram it on there. Why does it only work with indeterminate form? I don't know the answer to that because it's the indeterminate form rule. Because the other ways have other rules. I guess is what it comes down to. That's a good question, though. I will find that out. I bet you somebody knows. I don't know the answer to that. Okay. Let's do A here. So it says, let f be defined by this function. Let g be a differentiable function. The table gives values of g and its derivative g prime, its selected values of x. Okay, so we're going to do the left and right stuff here. So the limit as x approaches -4, not the left and the right, top and bottom, sorry, of g of x minus 5, and the limit as x approaches -4 of 2 h of x minus 3. Right. Since I can't see that, let's see. So when I substitute it in, g of -4 is what? 5. So that's going to give me 0, right? Then g, when I substitute in -4, what's h of -4? One half. And so this ends up giving me 0 also, right? Got to look at the graph for that one. So that means I have to use L'Hopital. So I will say, therefore, by L'Hopital, I'm going to do the limit as x approaches -4 of, that'll be g prime of x, and that's it in the numerator, right? What does the denominator give me? Well, that's the derivative to put in the numerator. What am I putting in the denominator? 2h prime of x. Okay. Is h prime of -4 0? Okay, just making sure it's not 0, right? That way I don't have to. So I can go from here. What is g prime of -4? -1. And then 2 times, what's h prime of -4? 1/2. So that gives me -1 over 1 is -1. Okay. What questions you got? All right. You work on B while I hand out a couple of things. H of 2. H of 2. Well, how are we going to know what that is? Okay, the slope is negative 1/3. So that means that this is at negative 1/3, negative 2/3, negative 3/3. So H of 2 is actually negative 2/3. Use the slope. Oh, H prime, thank you. Oh, wait. Oh, I'm sorry, I found H. Wait, what are we looking for? Oh, you asked for H. Okay, yeah. So I had it right the first time without the prime on it. Yeah, so H of 2 is negative 2/3. H prime of 2 is negative 1/3. Yeah. Do we understand why they're different and what they are? Okay. And you got to make sure you do your derivatives correctly, right? So this is going to give me negative 2/3 times 2. Yeah, same answer. What questions you got? You know all those rules you hate? You forgot one. I was talking to him. All right, so I handed out 2 things. I handed out a test review, and I handed out a worksheet on L'Hopital because the review, L'Hopital's on the test, but it's not on the review, okay? Whether or not you do all the worksheet or not, that's up to you. I will have the keys to both in the binder for tomorrow.